All right, so continuing this lesson's reviewing factoring. You want to look at factoring when you have a trinomial, but you don't have a coefficient of 1 in the front, or if you have whatever coefficient you have in the front, you can't just factor out. And again, ideally, this sounds familiar. There's a whole bunch of approaches to take to this, none of which are incredibly quick. This definitely takes more time than some of the last lessons. First, I want to show the main sort of strategy, but it is a bit time consuming. So first, always when you look at any polynomial that we want to factor, look for a greatest common factor, but there is none. In this case, once we see there's no GCF, how do we approach this? Well, again, the whole point of factoring is we want to unmultiply something. We want to break it up, and eventually it'll take us a few steps to get to two factors. And these two factors should be, if they're correct, if we FOIL them out, we should collect like terms and bring us here. It's pretty tricky to do this all backwards. So one thing we want to do first is we want to break up this middle term. We kind of want to uncollect like terms, if you think about this backwards. And so I need to break up this middle term. And how do I do this? Well, first I pay attention to the first coefficient and the constant, and I multiply these together. And I go 10 times positive 3 is positive 30. And I think of two numbers that multiply to 30 and yet add to negative 17. Once I figure out those two numbers that multiply to 30 yet add to negative 17, I know how to break up my middle term. I know how to uncollect these like terms. And if I can factor this, there must be a pair of numbers, and only one pair of numbers, of integers, that multiply to 30, positive 30, but add to negative 17. And the two numbers that work are negative 15 and negative 2. So I'm breaking up that middle term to negative 15x and negative 2x. The order I write them down doesn't matter. And I'll leave everything else as is. And again, when you're factoring, you're unmultiplying. And so when we look at this backwards, this would be the last step of FOILing, in which we would collect like terms. My like terms would be negative 15x and negative 2x to make negative 17x. All right, well, that's it. We're factoring, so I'm going down. What do I do next? Well, now I want to look at these in pairs, and it's called factoring by grouping. And I look at this first pair that I've underlined in red, and I think, what's the greatest common factor of that pair? And there is a greatest common factor in that pair. It's 5x. And I take out a common factor of 5x, and I have 2x minus 3 left. Similarly, I look at this pair, and I think, what's the greatest common factor? And you may say, well, there is no greatest common factor. Well, yeah, no. You can take a factor of 1 out of anything, or a factor of negative 1 out of everything. Until now, though, it's not very helpful. However, notice, if I take a factor of negative 1 out, that means I'm dividing negative 2x and positive 3 by negative 1, which means I have positive 2x and negative 3. And the point of doing this is now we have a factor of 2x minus 3 in common. I have this term here that is a factor of 2x minus 3 and a term here. And so I now do have a greatest common factor. I have a binomial common factor. And so I pull out that factor. I usually write it first. So 2x minus 3. That's one of my factors. And then when I take out that factor of 2x minus 3, what's left? Just a 5x minus 1. And again, this should be something you learned about in grade 10. Hence, I can do it fairly quickly. And notice if I go backwards, and I FOIL this out, 2x times 5x is 10x squared. 2x times negative 1 is negative 2x. Negative 3 times 5x is negative 15x. Negative 3 times negative 1 is positive 3. And so if you look this way, you're multiplying, and look this way, you're factoring. So we call this factoring by grouping, what I did here. And what I did here is great. It's really important. But in this course, we need to factor like this so often that having a shortcut would be very, very beneficial. Because in grade 10, the whole purpose was just to factor. But now that's not the purpose. The purpose eventually is to factor in order to do more with it. And we'll be factoring a lot. So while this is great, this idea of factoring by grouping, that's what I did here. So it's called factoring by grouping. I created these groups and took out common factors of each groups. However, what's a faster way of doing it? Well, there's a whole bunch. I'm just going to show you one method that I will be consistently using going forwards. So let me just copy down this exact same expression again. So we already know the answers. We know the factors of this are 2x minus 3 and 5x minus 1. But a slightly faster way of doing this, I'm one of many, but I'm just, like I said, starts the same as before. Multiply 10 and the 3 together, and we get positive 30. And we got to think, what are two numbers that multiply to 30 but add to negative 17? Well, again, those two numbers are negative 15 and negative 2. But this time, I'm just going to write those two numbers down, negative 15 and negative 2. Now, these are not my factors, but they're going to help me figure out my factors. So negative 15 and negative 2. With that said, what I do next is I look at my coefficient of x squared, which is 10, and I divide each of these by that 10. Whatever number goes here, I divide each of these by that. And now I inspect what I have here. For example, let's look at this first expression, this first term here. I have 15 over 10. Well, that reduces to 3 over 2. And over here, let me look at 2 over 10. That reduces to 1 over 5. Well, how does that tell me my factors? Well, notice if I write a little x right here and an x right here, if I take this denominator and swing it up here, I now have 2x minus 3, which is one of my factors. And if I take this 5, the denominator, and swing it up over here, I have 5x minus 1, which is my other factor. And that said, in terms of in terms of explaining why something works, I like this better. In terms of what's faster, I like this better. It is like significantly faster, especially with a bit of practice. In the end, though, I got the exact same factors, of course. It's the same question. But this particular shortcut is one of many. Again, I will, just to be consistent, so I'm not using different shortcuts throughout the course. I don't want to confuse you that way. I'll consistently use this one. And again, though, if you're familiar with others, I really don't care, as long as you can factor pretty quickly. Again, in a grade 10 course, this is really, really important. But now we're trying to use this. And so going forwards, we'll be factoring so much that I'd rather us just be proficient at it and pretty quick with it. So for these next two, I want to factor it using that shortcut I just used. Okay, and so let me focus on this. First, look for a GCF. There isn't a GCF, but I want to multiply 2 and negative 6 together to make a negative 12. And think what two numbers multiply to negative 12 but add to negative 1? Well, the only two numbers that work are negative 4 and positive 3. Now, those are not my factors yet. A common mistake is to just think those are my factors. That said, I look at the coefficient in front of the x squared, the 2, divide each of these by that. And then now I can start to see my factors. For example, if I look at here, negative 4 over 2 is exactly 2 whole. It reduces to a whole number. So one of my factors is x minus 2. I'm done that. Next, 3 over 2 doesn't reduce. Okay, but it's not a whole number either, so swing that 2 up. And my other factor is 2x plus 3. There you go. I'm done. It's really quite quick compared to factoring by grouping. But the key is realizing this step in the middle was really important. You know, those two numbers that multiply to negative 12 and added to negative 1, in this case negative 4 and positive 3, were not my factors, but they led me towards my factors. My factors are right here. And if you're ever unsure, FOIL it out. You'll get back to where we started. So similarly, let me do the same thing here. Again, it should be relatively quick. Look for a GCF. There isn't a GCF, so multiply these together. I get positive 6. What multiplies to positive 6 but adds to negative 5? The only two numbers that work are negative 2 and negative 3. Take my whatever coefficient is in the front. In this case, it's a 2 again. Divide each of these by 2. And now I can see my two factors. One of my factors from right here, I can see is going to be x minus 1, because 2 divided by 2 is 1 whole exactly. Done. My other factor is going to be from right here. 3 over 2 doesn't reduce, so I just swing the 2 up there, and I get 2x minus 3. Okay, so as with the last lesson, I now want to look at some similar examples that seem unfamiliar, but will all kind of connect. Okay, so let's look at these two, and I'll focus on the one on the left first. Now from the one on the left, we now have these x's and x squareds, and we saw this sort of stuff in the last lesson. So you have a few options as always, but for this one, what I'll do is say, okay, let's say you're unsure what to do. Well, like ignoring the y for a moment is a perfectly good idea, except I need to have a last term, so I just have a 1 there, whereas it used to be 1y squared. And now think, okay, what are two numbers that multiply to 6 but add to negative 5? So those two numbers that multiply to 6 and add to negative 5 are negative 6, and positive 1. Put an x here, put an x here. And then look at the 6 right here. Divide each of these by 6. Wait a minute. No, I made a mistake. I like to say it was a deliberate mistake, but it wasn't. However, it's a good mistake to make. The problem here is that negative 6 and positive 1 do add to negative 5, but they don't multiply to positive 6. Negative 6 times positive 1 is negative 6. So I need to go back a moment. And again, it's a very common mistake. Again, I had a wrong sign. And so the two numbers that multiply to positive 6 and add to negative 5 are negative 2 and negative 3. There we go. Negative 2 and negative 3 make negative 5. Negative 2 times negative 3 make positive 6. Now we're good. Divide each of these by a 6. Okay, keep in mind again, I'm ignoring the fact that we're actually y's in this question. But that's it. If I look at these, this here, this 2 over 6 reduces to 1 over 3. It's not a whole number, so I swing the 3 up and I see one of my factors, 3x minus 1. Over here, 3 over 6 again reduces to 1 over 2. It's not a whole number, so I swing the 2 up and I get 2x minus 1. And that would be the answer to the question if the question was factoring 6x squared minus 5x plus 1. So now what's left is realizing, okay, that wasn't the question. There was a y there. That was y squared, which means, if you think back to the last lesson, the only difference is this is not 3x minus 1, it's 3x minus 1y, and 2x minus 1y, which means I don't really need those 1's anymore. There we go. With that said, I don't fault anyone for looking at this and thinking that, maybe that was a bit too tricky to just ignore the y's till the end. So another option, which I'll do for the last one, is just to go back to factoring by grouping. If you're ever unsure, that factoring by grouping, the very first thing I did, will always work. Okay, and that may have been a better option for you if what I did here was a little too much, again, the very fact that I just ignored the y's for a while. That threw you off. Well, let me show you how, again, for this one here, I will just solve it by factoring by grouping. And so again, there's no GCF. So multiply 10 and negative 6 together, I get negative 60. What multiplies a negative 60 but adds to positive 11? 15 and negative 4. So this time I'm going to go plus 15t squared minus 4t squared. And so leave everything else as is. And again, I am choosing to do this just because I'm just pointing out how that factoring by grouping, while it can be a bit time consuming, it'll always work. And if you're unsure, do what'll always work. That's it. Look at this pair. What's the greatest common factor of these two? That greatest common factor of these two is 5t squared. Take out a common factor of 5t squared, and you have 2t squared plus 3. Look at this. What's the greatest common factor here? Well, 2 or negative 2. And if I take out a negative 2, I can get that same factor of 2t squared plus 3 inside the brackets. If I divide all those by negative 2, I get again 2t squared plus 3. And the whole point, if we're factoring by grouping, is to find this binomial that's exactly the same in both. And now I'll write that factor first. 2t squared plus 3, and what's left is 5t squared minus 2. Now I'm done. So notice again, compared to the last one, there is more work. It's not a ton more, but it is more. Lots, again, but I always want us to realize there's always lots of options. I never want anyone to think there's one way of doing something. Quite often there's one most efficient way, or a few more efficient ways. And so the last problem, little application problem here. I got this circle, and I have the diameter kind of labeled right here, distance all the way across. So I want to find the expression for the diameter given the area. So that what you see here, 9 pi x squared minus 12 pi x plus 4 pi, is the area of this entire circle. So from that, how can I find the diameter of this circle? Well, first, let's remember, how do we find the area of a circle? One of our classic math formulas, it's pi r squared. So That's the area in general. This is the area of this particular circle. What do I want to do first? Well, it's probably not surprising that factoring will come into play. And if you're ever unsure and you think factoring is going to come into play, you should always look for the greatest common factor first. In this case, there is a common factor of pi that I can take out of all of these terms. So let's take out a factor of pi from all these terms. And the reason that's helpful is if you compare that to what I have for the area formula down here, is I can see a similarity. I'm trying to basically recreate this form here of pi times the radius squared. If I can figure out the radius of the circle, it's pretty easy to find the diameter. All right, that said, this right here, 9x squared minus 12x plus 4, must be the same as the radius squared. It has to be. Again, the area of a circle is pi times the radius squared, which means what you see in pink must be the radius squared. Which means if I can factor this, I should get the exact same factor twice. I should get the same factor repeating. And that factor should be the radius. So I have a few options. I'll mention one way of approaching it, and then I'll mention a faster way. I could just now look at this and go, what I've been talking about. 9 times 4 is 36. Think of two numbers that multiply to 36, and yet add to negative 12. Those two numbers are negative 6 and negative 6. Not surprising, it's the same number. Because again, I know in the end, my two factors should be the same. Something times itself to make the radius squared. That's it. I have a 9 right here, so each of these should be divided by 9. And again, these are not my factors, but these are going to let me know what my factors are. Each of these reduces to 2 over 3. Which means I can see the two factors. The two factors I can see must be, if I swing up to 3, must be 3x minus 2 and 3x minus 2. And so by learning what we were doing in this lesson, I factored 9x squared minus 12x plus 4 to get 3x minus 2 times 3x minus 2. What would have been a little bit faster is if, like I said, once we realize that everything you see highlighted in pink must be the radius times itself, which means the two factors must be the same. And you can kind of actually speed this up a bunch by just realizing, okay, whatever goes for this first term, they have to be the same. And they have to multiply to make 9x squared. So you have to be 3x each. And whatever goes here and here has to be the same. It has to multiply to make 4. And yet has to have a middle term that's negative. And depending on how proficient you are and confident you are with some works from Math 10, you could speed this up a bit, but honestly, who cares? That didn't take me that long either. And so notice that means this particular circle, the area of it is pi times 3x minus 2 squared. You can see exactly how this particular area is in the same form as the formula for the area of a circle, which means 3x minus 2, that must be the radius. That's the radius. And so I want the diameter. And so the diameter is going to be, I'll say, therefore, the diameter is going to equal 2 times 3x minus 2, or 6x minus 4. There's our diameter. And so keep in mind, if I pick a number for x, plug it in, I got the area of this particular circle. But again, I don't need to do that. I'm done right here.